Okay, so on number 17 from your review, it says use the given information and the theorems you have learned to show that R is parallel to S. Anytime you're asked to show that things are parallel, you know you're going to use a converse. So we're going to use a converse theorem. So first off, if I know that x is 50, I can plug in 50 and say this is 2 times 50, which is 100. And this is 50 plus 50, which is also 100. So the measure of angle 3 is equal to the measure of angle 7. Okay, that tells me that those two angles are congruent. I would probably be okay for this type of problem with you not giving me a reason for those. But I would say, if you wanted to say the reason we know these two are the same measure is because they both equal 100, so that's transitive. And the reason that tells me that they're congruent is the definition of congruent angles. Okay, and so then I would say, what kind of angle pair is 3 and 7? It's alternate interior angles. So I'd say, so R is parallel to S by alternate interior angle converse, or the converse of the alternate interior angle theorem. Okay, and you may not have to show quite that much work, but you need to at least show me that you're plugging these in and that you see that they're the same, and that means the alternate interior angles converse says the lines are parallel. All right, number 18 gives me this picture, and it starts out with the given information, which is that P is parallel to Q. So on this, we're starting with the lines being parallel, so we're not going to use any converses here. Okay, the next thing it says is that I should use the linear pair theorem. There's only one linear pair in this picture, and that's 2 and 3. Okay, the linear pair postulate, it's actually a postulate, not a theorem. What it says is that linear pairs are always supplementary. So in other words, 2 and 3 have to add up to 180. So that's what I'm going to say here. 2 plus 3 adds up to 180. And since I'm adding and using equals, I use the M. All right, then next, angle 1 is congruent to angle 2. Well, let's look at the picture and see what kind of angles those are. So we're saying these two are congruent. Those are corresponding angles. And because we already know that P and Q are parallel, corresponding angles are congruent by the corresponding angle postulate. If you say theorem accidentally, that's fine with me. So corresponding angle theorem or postulate. That's a P-O-S-T. All right, next, definition of congruent angles. Anytime you see definition of congruent something, basically we're going back and forth between saying they're congruent and saying that means the measurements are equal. In other words, what it means to be congruent, it means for these to be congruent that their measures are equal. So I just say that. You can use definition of congruent angles to go from here to here or from here to here. Either way. And finally, the last thing on the statement side is always going to be the thing you've been asked to prove. So let's think about how we have gotten here. Well, look at what this looks just like. This looks just like what we had up here in 2. These look just the same except for one part, and that is we replaced the measure of angle 2 with measure of angle 1. And the reason we did that was because they're equal to each other. When you plug one thing in place of another thing, that's called substitution. So that's what we did. So that's substitution property. Technically, it's the substitution property of equality, but I'm fine with just using the word substitution.